Hey everyone, Samuel from Tech with Sam here. So it's been a couple of months since my last video. Life happens, so I took a break to recharge and rethink how I want to serve this community. So I'm back now with fresh energy, and I'm starting a brand new series called AI Engineer for Flutter Developers. So this series is not about hype for another AI tool review. It's about helping you to become a better AI engineer as a Flutter developer. And what does that mean? It means someone who can thoughtfully integrate AI into mobile apps, understand the concepts, make smart architecture decision, and shape reliable features. So in this first video, we are starting from the beginning, that is mindset shift, key concepts you need to know, and building your very practical AI features using Gemini and on-device models. So if you have been feeling overwhelmed by all the AI noise, this series is for you. We'll go through some concepts and also mindset shifts. So one of it is most developers right now are AI users. That is, they copy code, they copy prompts, paste code, and hope it works, and just trust it that it is. As a Flutter developer in 2026, we need to become AI engineers. And what does that mean? That is, becoming AI engineer, it has to do with 4 major concepts. That is, you understand when to use on-device versus cloud AI. You know how to evaluate quality and undo failures. You design proper architecture around AI features. You care about privacy, performance, cost, and user experience when it comes to integrating AI. So that's pretty much on what AI engineer is all about, essentially. So this series will as well help you make that shift to better understand AI engineer as a whole. And before we dive into live coding and going through some concepts, I would love to share like some key AI concepts every Flutter developer should be aware of, should know. So we just quickly cover some most important concepts without the jargon overload, and I'll just go through 6. So the very first is LLMs, that is large language models, which includes, we have the likes of Gemini, Cloud, Codex, Kimi, and so on and so forth. So those are LLMs, large language model. The next point is embeddings, that is turning text, images into numbers for compression. So those are embeddings. Then we have RAG, that is retrieval augmented generation, that is giving AI your own data for use. Now then the fourth point will be tool calling or function calling, which is letting AI trigger action, that is AI performing an action just like Cloud Desktop. Then the fifth point will be agents, basically AI that can plan and execute multiple tasks on your behalf. So basically Cloud Desktop also using it as an example. Then the sixth point will be on-device AI, that is running model locally for privacy and speed. So that is on-device. Then we can use like machine learning, which stem from TensorFlow and all. So we use all this throughout the series. We'll be starting simple today, so we'll just be the basic comparison between cloud and on-device AI. So just be building that in the course of this series. So that's what we'll be doing. So now we'll be using 2 main package, and by default, we have this package, which is Google Generative AI, although it's depreciated already, as you can see here. So the Google team has stopped actively working on this particular dependency because they have combined everything to Firebase AI, which is the Firebase AI logic. So everything now stems from Firebase AI. So let's say Firebase AI. So if you go to Firebase AI now, so everything now stems from Firebase AI. But with this, you have to have Firebase set up, and also, but you don't want to. But there's another community project that already exists, which is Google AI DAT. So with this, it's a DAT project actually that has all the concept for Google Generative AI as well. So this is the package we'll be using in this particular tutorial. In this video, so we go in advanced later on. In the next couple of videos, we also use Firebase AI logic and Jenkins and some other AI tools. We go deeper in the course of the series, so stay tuned. So Now we'll be using this Google AI that's for Gemini for Cloud AI. Then we'll be using this TensorFlow Lite, basically TensorFlow Lite filter package for the on-device AI model as well, to run basically inference and to get quicker response without even needing to listen to what's it called, internet, basically TensorFlow Lite interpreter, as you can see. So TensorFlow Lite provides Flutter plugin provides a flexible and fast solution for accessing TensorFlow Lite interpreter. So that's what we'll be doing in the course of this tutorial. So now to get started now, so I will move to the code part. So by the way, I've generated this code, and for you to actually follow adequately for this series, you should have some level of knowledge in Flutter development already. So I won't be going code to code to be explaining everything. What we are here for is basically to understand the whole concept, how to better use AI, to better shape AI features, and how to be effective in doing so, not going through lines of code one by one. By the way, you might have guessed this code is generated by Gemini AI as well. So it's not about the code essentially, it's about the whole concept and understanding the flow of how to ship AI features, and also when to use on device and when to use cloud AI. So that's the purpose of this series. So now we just start again. As I mentioned, if I go to PubSpec YAML file, now you can see the main two packages is Google AI, that, and TS Flight. Now Flutter, the two packages I already installed, and we just go through the whole flow. So this is the text analyzer. It's just model for to get the response. So what we want to build essentially is like a simple separation that is comparing on device and cloud AI. That's what you want to do basically. So basic Gemini core and simple on device model setup. So basically for classification model. So now for Gemini, this is the architecture. This is the model. So inside the model, we have the summary, key insights for the action we actually want to perform for this particular video, for this project we're building. So basically, it's just a comparison between two texts. Let me show the app. So let me refresh. I was actually testing before actually recording this video. So as you can see, it is like side-by-side hybrid analysis. So on device, and this is cloud AI. So this is on device, this is cloud. So that's pretty much about it. So we just input a test, and we analyze it with both cloud and on device. That is Gemini and TensorFlow Lite here. So this is the model for Gemini. So we get the summary, the key insights, the action, the tone, and the response from what we actually want to get. Then this is for what's it called, on device. So sentiment, that is emotion, feel, probably what's it called, positive, neutral, negative. So we already set this. And also for the on device classification as well. So we have all this model structure again to it as well. So that's pretty much so the text analyze result. This is just a model that collects all the data that we'll be getting from Gemini and on-device classifier. So now to the service, to the main point. So we have the Gemini service. So the Gemini service basically is where we are integrating Gemini itself. So we just do a quick walkthrough. We use Gemini. So what we're using Gemini for is we are using Gemini to summarize or extract insights. Then we use on device for quick classification, that is sentiment or category. So there are two different things. So Gemini is to summarize or extract the insight from a particular user input. Then we use on device model for quick classification or category. So basically, then we show both results side by side, and that's what we have here again. So now I will walk you through. I'm I'll walk you through the service layer again. Also now, this is the Gemini service layer. So basically for the Gemini service, basically you need an API key and the model. So the model name now, the model name simply means basically the AI agent you want to use. So if you go to this Google Doc, that is ai.google.dev/Gemini API.doc, like this, you go to all the models, you see all the models we currently have here. So Gemini 3.6 Flash, Gemini 3.5, and so on and so forth. So you can just scroll to choose the one that that's compatible to what you want. So some models has different specification. You can see this Nano Banana now is mainly for image generation and editing. So it's not for text it's not for generative text and stuff like that. So they have different scopes. So based on your use case, you can just copy it. So I can click on it. You can see that in the video, in the code base, I'm using 3.1 flashlight, which is this. So if I click on this now, it will load, it will open up the model. So you can see this is the model code, and that's exactly what I have here as well. So this is the model code name. So the code, the support data type test, you can see the type test, input, video, audio, PDF, and stuff like that. The input token, you can see all the information literally from each of these models. So this will better explain if the model is it's actually it can achieve what you want to use, your use case. So pretty much on that. So once you select a model, then we can now start with analyzing the input. So now basically we are using the Google AI, that package that I mentioned earlier, which is Google AI that package to run through Gemini, basically Google Cloud AI as well. So the first thing is you need Google AI API key rather. So to get that now, you can easily just go to Google AI Studio. So if you head over to aistudio.google.com, it's just easy. You can just set up an account, easy peasy. You don't need to add your credit card or whatever. You can just set a test. As you can see, this is like a test key. You can see the date that I've created this key as well. So majorly you can just use that, copy the API key to run some tests and all. So now I can go back now. So you need the API key, and as you can see in the app now, this is this icon. I can paste the key here just to I can paste the key now. So this is the Gemini key to actually have access to the Cloud AI Insight here. So without that, it won't work. I will clear it later. I will refresh. I will restart the app, so it will clear off because this is not saved anywhere. So you just save on the on compiler actually. So I'll refresh it. So we'll try like running some tests and see if by the time we are running the program, if without the API key it will run fine also. So pretty much this is just assumption catch to check through, and also the texts, and but this is where the major work is. So this is where we instantiate the client using Google AI config and the API key provider from the Google AI that package. So basically we get the API key which we provide to this API key provider. This is from the Google AI .dat package itself, so the API key provider. So this actually encrypts the API key so it won't be exposed during runtime. So the purpose of our smart test analyzer is basically to go through a different test so we can get classification in one part and also the summary with our Cloud AI Insight. So now the prompt, behind the scene of all this prompt, as a user, we just want the user to give a simple test, then we give more information to the AI model so the AI model can better understand what we want to achieve for this particular prompt, and that is exactly what is happening here. So this is like the behind the scene. So majorly what you are saying here is analyze the following text and extract structure inside, return only a validation object, that is JavaScript object notation. So in this format, summary, a concise 2 to 3 sentence summary of the key message, the key insight, a list of 4 main takeaways, action points, a list of relevant action items or follow-ups and so on. The tone, overall tone, if it's professional, urgent, enthusiastic, frustrated, and informative. So basically, we are telling the Gemini AI model to return a JSON format in this format. This is the key summary, key insights, actions, action item, and tone. And if you notice, we have structured the model in the what's it called, in the format that we are expecting from Google AI. You can see that we inform the Google AI to give a response based on this particular structure, and we have already set our model. So inside our model, you can see the summary as well, the key insight, action item, and the tone, and the raw response in the JSON format itself. So this is what the AI model will the results will look like. Then we'll transform into a readable code that we can show to the user to better adjust. Then we can also have the raw response. So that's pretty much. So then we can now say test to analyze then what the user input. So you can see that behind what the user input, there's still a lot more going to the AI model. It's not just literally what the user input essentially. So pretty much. So now the next thing now is to send a request to Gemini API. So we just send him first of the model, which is the 3.1 flashlight. Then we generate what we want to ask for. So the prompt. So this is the prompt again. So you can see this is the prompt. Then the row. So there are different rows. So if we go through the documentation of generative AI now, you can set different rows for a particular use case. So one of it is user. So you can just go through it, but for most use case is user. So like that. So the next point now is to extract the generated text from response candidates now. So by the time we have gotten a response, then we can extract it so we can better feed it to this model that we have created here. So then that's what you're extracting here. So if the response is empty, then we can return a beta exemption. And if there's an error, we can as well return an error. Probably the API key is not submitted or anything that might happen, probably network issue or whatever that can happen during network call. So pretty much what you're catching here, then we are passing the raw text to our model so it can be better formatted. So now that's this is an effort to pass JSON response from Gemini so to the model. So you can see the summary, the key insights, the action item, the tone that we are getting, and the raw text, basically what Gemini is returning to us. And that's pretty much it. So by the time we are running we input a text, we analyze it. The Gemini is giving us a JSON, whereas we are analyzing it. We are restructuring it so it can be readable to the user. Then we can actually have access to the raw JSON data as well. So pretty much on the Gemini service. Now for the on-device classifier. So on-device classifier run as it does not require any internet connection. It's like a machine learning model that it's used for classification purpose to see different what's it called, token scoring majorly, and that's what all this is all about. So if we go through the document, documentation again, so if I just go to test flight, so let's just scroll a little bit. So so you can see now, so performing inference for TensorFlow flight now is basically rescoring creating an instant local token scoring. So that is what we are doing here. So for the positive word, we have positive, we have negative, and category keywords. So all the category because of the purpose of what we are doing here. So that's what this is all about. So we can have this customer support. You can say for product feedback, that's feature. Basically what this simply stands for is that depending on the category of what the user input, it will categorize it into. If it is product feedback, then it will add all this hashtag, which is feature, UI, and so on and so forth. If it is customer support, it will add all this hashtag. If it is tech inquiry, it will add all this hashtag. Not literally all, but the related one. So that's pretty much if it's urgent request, general information, and so on. So pretty much category keywords. So it can just fetch from what we have set already based on the user input. So that's pretty much. And for the positive word, you can see like all the words already have a score. So we assign a score to each word. So great, excellent, and so on and so forth. So they can have a scoring. So based on, because the on-device classifier return each, not as like an actual raw text as it is, it returns in lexicon dictionary. So that's how it's able to like read the data, and we can better detect, okay, if it's returning a positive word or a negative word, or it's neutral, essentially. So now another thing is TensorFlow Lite. Normally there's an asset load, so we can actually get an interpreter if asset is provided. Again, going through the documentation now, you can see, now let me just quickly go through, I think, yeah. So now creating the interpreter, creating the interpreter. So creating the interpreter now. So you can see in the dependency section in pub add, this is if you have the what's it called, interpreter file, and the you can customize the machine learning DML depending on the solution you are trying to create. So you can actually customize it in different formats. If you have the the TS flight model file, so you can have that. So you can actually load the model from your assets, from your Flutter asset folder, just like normal image and all. So you can have that for a specific use, for personal use and stuff like that. So that's that. Otherwise, we can just use the general machine learning model. So this instance now is just like an option in case if there's an asset. If there's TensorFlow assets folder inside our projects, we can run that to run through every task we want it to actually perform. Otherwise, we'll just run through what is necessary. So now classify text locally on device, measure inference latency. So now inside this function, we created a stopwatch majorly to track how many seconds it took the on device ML to actually get a response. So it will give us like a timestamp that is 30 seconds, 20 seconds, 5, whatever, and the amount of seconds it took it for actually to decide how to classify the user input, to give it a category and to give it a rating, basically. So that's what this is all about. So pretty much. Another thing is running the TFL model interpreter. So this we just check if it's active. So once it's active, then we'll run the inference. So the inference is the one actually classifying everything based on the scores that we have set already. So like the positive, the negative. So it will look for those keywords. If probably the user feedback now, it will look for the scores and the user tone of voice. So it will give a response based on that. So pretty much, so these are all on device LLM categorization, positioning for the dictionary use. So for the positive part, it return this sentiment score. So and product feedback for different feedback purposes, and also to restructure the output, to tokenize the output, essentially. So pretty much what the on device is all about. So now let's move to another file. So this is just a key dialog. This dialog I opened earlier. So the Gemini API key can be saved on compiler. So that's pretty much it. Nothing interesting here. So the results card inside this card. So you can see everything is structured to what we need. So basically just loading this Gemini service file. That's what we have here. So to return a response, and also to structure what we are fetching, so we can, like, for example, key takeaways, it can be it can have like be numbered or have some different points and be customized, so it won't just look like regular text majorly. So on device result as well, so this is just creating a design for the response that we're getting for on-device text as well. So this sample text pretext is basically I've set some text, so we don't have to be typing manually. So this is just for test purpose. So I can click on this positive review. So I already set some text here. So you can see positive review. So these are texts. It will just fill it. You can see I love the text says, I love this smart analyzer. The UI design is super clean, smooth and fast. It resolves all my workflow bottleneck immediately. Highly recommended to everyone looking for a great performance. So this is a user feedback. You can see that is a positive review as well. So now we can analyze it and see what our on-device classifier will say, and Cloud AL as well. So I just run it. So you can see now, you can see sentiment analyze is positive, confidence 91%, based on all the keywords that is inside this text. The love, smooth, the positive feedback, you can say highly recommended. That's all the score that the on-device model classifier was able to like capture. So you can see the case category and intent as well. Product feedback, again, if you remember, I mentioned that the product feedback we mentioned here with the category keywords. So you can see product feedback and all the points that are mentioned, low, smooth, fast, resolved, and so on and so forth, performance, and all. So these are like the key terms detected in our text. Basically, you can see the user saying I love. So it's basically some of the exact keyword that you just extract. And for our Cloud AI insights now, we're able to like extract, give Google AI model to summarize the user feedback. So you can see summary. The user is highly satisfied with the smart text analyzer, specifically praising it into the intuitive interface and high speed performance. That note that the tool has successfully resolved its workflow bottleneck and recommend it for others. And the key takeaways, you can see that the key takeaways has been redesigned. It's not just a normal text. So this is because of how we have structured the model as well. So you can see the UI is clean and so on and so forth. So this is like two different. So now let me refresh. So the API key will be inactive. We can see when the API key is inactive, it shows the what's it called, yellow icon or amber icon. So let me just select another one. So let me analyze. You can see what's it called, the confidence is 82, a negative feedback. This is urgent support. Urgent, our product database server crash after latest billing update. So ASAP, so is a negative feedback, urgent request. So you can see for the API model, API key is missing and is required. So pretty much everything that is needed. Yeah, so everything again, basically what you are trying to do in this video is that we are trying to get difference between AI user and AI engineers, how to actually classify both the core concepts you need and also how to set up Gemini basically, and basic on-device AI as well. So again, to set up Gemini, it does not require much. Just head over to aistudio.google.com, create your account, and on the API key side, you just generate an API. You can say create API key. I already have one. You can create multiple as well for different use cases. Like for different projects now, you can create different API key for it, and also set your billing if you are doing he has like some free plan. So if you're exceeding the threshold for that particular free plan, then you have to create a billing, and I believe it's pay as you go as well. So that's setting up Gemini, and once you set it up like that, you can just come to your Flutter code, and using the Google AI dependency, we can as well just make requests to the Google AI client pass our prompt and get a response, and the response now we can structure it the way we want, and we better understand how the response is coming, so we can better structure it in our code, creating a modem and all sorts. So that's basically your first working AI feature in Flutter. So this is just the foundation. I know that this might be relatively simple, but this is just the foundation. The real power comes in the next video. By the way, before you go, I have prepared a free AI starter packer for you. So it includes all the code from this video, setup guide, reusable components, prompt templates, and a few exclusive extra. So you can download it for free at the link in the description of this video or in the comment. So just enter your email and it will be sent to you straight away. So make sure to do that. And as well, if you find this valuable, if you find this video valuable, please hit the like button, subscribe, and turn on notifications so you don't miss the rest of this series. This is just video 1 of the AI engineering for Flutter series. In the next video, we'll go deeper into building reliable production ready AI feature. Drop a comment and tell me what's one AI feature you want to build in your Flutter app, and I would love to hear your feedback as well. I just started using a new recording software, so let me know if this video actually makes sense. I would love to receive your feedback. Again, thanks for watching. Welcome back to the journey with me, and I will see you in the next video. Take care for now. Bye.